Hi, this is Frank Hill, and I'm going to talk to you about the Arduino microcontroller. I'm going to talk a little bit about its origins and what kind of task it can carry out, and also some manual functions um, that preceded the Arduino. The Arduino is one of many microcontrollers, and the first microcontrollers came on the scene in the early 70s. Basically, the difference between a microcontroller and a standard computer is that the functions are limited, size is smaller, and it can be contained on a single chip or a very small board, and it's also lower in cost. With the advent of what is now called the Internet of Things, microcontrollers have um, ramped up exponentially. That is, that there are just thousands of millions of applications that didn't exist previously. Let me talk a little bit in general about microcontrollers. A microcontroller is a small computer on a single integrated circuit. That would be one chip, or on a small circuit board, as the one in this diagram is shown. When they're on a circuit board, there are other components that are added to um, for additional functionality. They have been around since the early 70s. The first calculator was actually a microcontroller by Texas Instruments. Um, Today they're used in washing machines, cars, microwaves, phones, toys, and most recently there are devices that control lights in houses and the thermostats and cameras and switches for all kinds of appliances. So um, there are literally tens of thousands of applications now that use microcontrollers, um, and more will come. This presentation in particular is about the Arduino microcontroller. The Arduino is very popular. It's low in cost, easy to use, and you can write small programs to control many different kinds of devices. And you also can plug additional circuits into the Arduino to do things like connect to the internet or control a robot. Um, it's made from open source software. The hardware is open source. That means that you have access to the design of the hardware and all of the software that's available. You can modify it and use it within limits. Uses a C++ development environment, and it's called, this development environment is an IDE, Integrated Development Environment, and is widely used by new developers and hobbyists, and it's a great way to gain experience with microcontrollers in general, and particularly if you want to get into the Internet of Things, which are controlled over the internet to do many, many things. And this is sort of the way the technology is going. So having this skill is very valuable. Basic capabilities of Arduino or any controller is that it takes input It does processing and it generates output. The Arduino can read ones and zeros. Ones and zeros are basically on and off signals. It can also read signals at different levels in a voltage range. Let's say if we're working with a high of 12 volts and a low of 0 or ground. We can also detect any voltage in that range. And in detecting those voltages, we can perform calculations. So we can also, as a result of programming, we can write ones and zeros out to um, pins that can control other devices. And we can do the same thing with analog signals. We can put out analog signals. And basic function of a computer is to execute algorithms. For instance, suppose we had two inputs called X and the other was called Y. And what we wanted to do is to do a calculation each time we received those two inputs. And we wanted to square X or multiply X times itself. And then we wanted to add Y to that value and then subtract 1. This is an algorithm or a basic calculation, and it's the kind of thing that Arduinos are very good at. This diagram shows a very simple circuit. We have a battery, and we have a light that we want to control, and we have a switch that's represented by this paper clip. We have the minus side connected to one side of the lamp, and we have the paper clip connected to a terminal, which is connected to the other side. Now we have the positive side that's connected to this little nail here. And if I want to turn the light on, I can just move the paper clip down on top of the nail, and I have a complete circuit where current will flow this way through the switch and to the battery. And I have a complete circuit. The light will illuminate and my circuit is complete. Similarly, if I move the paperclip off of this nail, it will break the circuit, the current will stop flowing, and the light will go off. This is an operational switch circuit. That is, it contains a battery, a LED, and a paper clip for your connection, and it actually works. So what I'm going to do, as I described in the other demo, is I'm going to take the paper clip and put it on this terminal, and notice the LED comes on. I take it off, the LED goes off. Okay, so this is kind of a mechanical switch, just something to give you an idea of how a switch physically operates. And again, let's trace the current flow. Current flows from the battery, that's the negative, goes down through the LED, through the paper clip, around to the positive, and then it circles again. I have another circuit which does actually the same thing as the previous circuit. It's a little bit more formal. It uses a regular manufactured push button switch. It also has a resistor, which is a device that sort of limits the current so that I don't burn up the device, this LED here. And I have a battery, similarly. I have plus connected to the resistor to one side, minus connected to the other side. And when the button is pressed, the circuit is complete and current will flow from the minus through the LED through the switch to the plus side, and it will continuously flow as long as the button is pushed. When the button is released, breaks the circuit, LED goes off. And that's basically the way all switches work. Now this is the same circuit, but it uses a store-bought switch. Here's the LED, here's the battery, here's the switch. And I can push the button and turn the light on. I push the button again, it turns it off. And these circuits are the same. The difference is that this is a more conventional switch, and you can't see the inside of the switch, but it's push on, push off. Okay, let's have a basic discussion about ones and zeros. A one generally, not generally, a one represents a high value or a positive value from some voltage source. Let's assume a 9-volt battery. One of the terminals has 9 volts, and we can call that the plus, and it's marked on the battery plus. The plus represents a logical 1. And if we put that 1 to a light or a circuit that could be controlled by the voltage, it will turn it on. The second terminal has a voltage which we will call minus, which represents 0. Ones and zeros signals are used to turn things on and off with computers and microcontrollers. In your first project, you will use ones and zero to turn LED lights on and off. Ones and zeros can control most devices that are in use today. Occasionally, you'll want to put analog signals out that is something between 1 and 0. In the case of this 9-volt battery, maybe we want to put out 6 volts to control some device or make it do something. But ones and zeros are often spoken of as binary, that is on and off. And in computers, it is the basis for many functions. At this point, we're going to start building software applications that run on the Arduino. I want you to start by going to the URL shown there at www.bdpa-camp.org/working.html and download the file for the week 6 project. Next, we're going to do a few introductory programs. One is Blink. Another is a program that just simply turns on a light and then turns off a light. And we're going to do a control program which turns lights on or off based on a switch action. Not this day, but our next Saturday, we're going to work on a stop light program and temperature sensor. This is your Arduino trainer board, and I need you to take your USB cable, and here's the end that plugs into the Arduino board, and plug it in like so. Take the other end and plug it into your USB port on your computer. Like so. And you see there's a program that's running. I'm going to reset that program. I really need to wipe that program out totally. So let's wipe that out. Okay, here's what we're going to do. This is a blank program. Assumption is that the Arduino has been installed and you have clicked on File and New to start a new program. And so you get a blank window like this. And you have a couple of sections. One section is things that you want done before the program runs. And this section down here for loop is what will be done within the program again and again and again. Okay, so let's go and get our code for the setup. Okay, for setup, I want you to type this code that you see here. The first line is just a comment that says what it does. The second line sets one of the output pins. If you look at the little black connectors, they're all numbered. And you have one pin that's 13. And this setting says that it's going to be output. That is, it's going to control something, turn something on and off, ones and zeros. And now in the loop, we need to define how it's going to do that. And I have another command that's called digital write. And it says I'm going to digital write to pin 13. I want to make it high, and which means I turn it on. I'm turning the voltage on to high level. I delay for 1,000 milliseconds, which is a second, and then I do it again. And it does this until I stop the program. Very simple. Now I need to compile a program that is check to see if it works. And I do that by clicking on, well, let's do something else first. Let's make sure we're set up properly for the board. So I go to Tools, and I see that it's a Arduino Desamila board. And if it wasn't, if it was a different kind, then I would select it on the right. It's on COM4, which is correct. So now I'm going to check the program, verify it, see if my code is right. And it compiles. And it says my code is correct and I don't have any errors. So the next thing I want to do is load it into the Arduino. And you see it being loaded. Now, once this program has been loaded into the Arduino is going to turn on a red light or yellow light that's closest to your USB connector. And that's all it does, is it turns on that light that's on the board. Next thing I'm going to do is run another program that turns the light off. And you're going to see I'm going to make just a simple change here. I'm going to change this high to low, which means the program is going to set pin 13 low, which takes the power away from the LED, and it's going to go off. And so let's go ahead and upload that. And what you should see now on your board is that light has gone off. Now the remainder of programs are going to be loaded the same way. I'm going to give you a piece of paper to type those programs in, and then from time to time I'll tell you how to change it. So this is our start, our beginning of Hello World.